Hello, algebra students. Mr. Lawrence here, and we are going to do some mixture problems, some story problems. And these are actually really easy, but you have to take them slow, and I strongly suggest you always define your variables. Some of the honors kids wouldn't define their variables, and they were just too lazy to do it, and they'd get these problems wrong, but they're really simple. So let's take a look at the example number one here. A chemist has a bottle of 20% acid solution and a bottle of 40% acid solution. Okay, he needs to mix them together to get 200 ounces of a 33% solution. Uh, so you see he's going to take a little bit from the first bottle and a little bit from the second bottle. He's going to mix them together. He knows that if he pours some of the 20 into the 40 will get weaker, right? It's kind of like if you make chocolate milk. If you put some chocolate in and some milk, you get a glass of chocolate milk, right? But when you make it, you put way more chocolate in it than when your mom makes it, right? Mom makes it, it's like gray white milk. You can barely taste the chocolate. You make it, it's almost like drinking mud because you put so much chocolate in there, right? Come on, I know you do that. All right, so let's see how to do a problem like this. It's really pretty easy. The first thing I'm going to do is I'm going to define my variables. I'm going to let x equal the ounces of 20% acid. I don't know how much I'm going to take from the bottle of 20% acid. It's going to be X ounces. I'm going to let Y equal the ounces of 40% acid. Okay? Now that I've done that, I'm ready to write my equations. I know I need 200 ounces, right? Well, I'm taking X ounces from one bottle, Y ounces from the other. So my first equation is going to be X plus Y equals 200. See that? That's the ounces from one bottle plus the ounces from the other bottle equals the total number of ounces I'm going to need. Now the next equation is easy once you have this one done. Okay? The X bottle is 20% acid, right? So I'm going to take the ounces and go 0.20 times X. The Y bottle is 40% acid, right? So I'm going to go 0.40 Y. And I went decimal times ounces, decimal times ounces. Well, I need 33%, so my last one is going to be 0.33 times ounces, 200. Now I'm going to simplify this number here. Hold on one second. To 66. So my two equations are x plus y equals 200 and 0.20x plus 0.40y equals 66. And now I'm going to choose to do this problem using substitution. So the first thing I'm going to do is I'm going to solve for x in this green equation. I'm going to x is going to equal 200 minus y. You could do elimination, or you could have chose to solve for y or something like that, but it's relatively easy to do it by substitution. Anyway, no, I didn't make any sense there. Sorry, I got distracted by Loki. All right, so I'm going to do 0.20 times whatever x is, 200 minus y. I'm going to add 0.40y. That's going to equal 66. Okay, I'm going to distribute just like this. And let me see, I need 20% of 200. I think it's going to be 40. So I'm going to get 40 minus 0.20y plus 0.40y. And that's going to equal 66. I'm going to combine these like terms. And I'm also going to subtract 40 from both sides. So my new equation is going to become 0.20y, and that'll equal 26. I'll divide by 0.2, 1/5, 26 times 5, thinking 130? Is that right? That doesn't sound right. Hold on a second. 26 divided by 0.2. Yeah, it is 130. Very good. Okay, so that means y is 130 ounces of 40% acid. Now to figure out x, all I have to do is do 200 minus the 130 I just figured out. So x is going to equal 70 ounces. X equals 70 ounces of 20% acid. And there you go. All right, let's look at another one. This time a gardener has a bag of soil that is 45% nitrogen and another bag of soil that is 80% nitrogen. He needs to make 80 yards of a soil that is 60% nitrogen. So you're going to mix them together. Well, first, let's let x equal the yards of 45%, and then y is going to be the yards of the 80%. Well, now I can write my first equation. I'm going to add x and y together, and that's got to equal 80. The yards from the one bag plus the yards from the other bag has to equal the total yards. Okay? And now I just do my percentages. I'm going to have the x plus y. That's going to equal the 80, but I'm going to multiply. The first one is a 45%, so I use 0.45 as my decimal. The next one's 0.80, and the result needs to be 0.60, and I'll multiply. And 48, I think. Yeah, 48 should be right. So that's going to be 48. Okay, I'm going to solve this equation. This time I'll solve for y. I'll get 80 minus x. So I'm going to substitute it in 0.45x plus 0.80 times 80 minus x. That'll equal 48. Okay, going to distribute here. And doing so will get me, hold on, I need a little more room to show my work, 0.45x plus, well, I'm going to get a 64. Yep, that's going to be 64 minus 0.80x equals 48. So I'm going to subtract 64 from both sides, but then I'm also going to combine my like terms, this one and this one. Okay, so when I combine my like terms, I get a negative 0.35x. Now, a lot of you screw up when you do this problem. Look, 5 minus 2 is 3, right? A lot of you have trouble when you do 2 minus 5. Look, it's the same problem, just do negative 3. Okay, so I'm not going to do 48 minus 64. I'm going to do 64. Sorry, let me start over. I'm going to do 64 minus 48, but I'm just going to make my answer negative. So I'm going to have a 5, a 14. Looks like it's going to end in a 6, 16, but my answer needs to be negative because the negative number, the absolute value of the negative number was larger. So to get epsilon, I'm going to divide by negative 0.35. Negative 0.35. X is going to equal approximately 45.71 yards. Okay, then to get y, it's real easy. Y is going to equal 80 minus 45.71. Okay, well, 80 minus 45 would be 35. So it's going to be 34. And then I got to make a hole. Looks like I'm going to need 29 yards like that. And there are your two answers. All right, let's look at one more type of problem. One day Bob was cleaning out his couch. He found a total of $9 in nickels and quarters. How many quarters did he find? How many nickels did he find? Well, we'll let Q equal the number of quarters. Oh, we can't do this problem. I didn't give you enough money, enough information. Hold on 1 second. Okay, I think I fixed my problem there. Sorry about that. So one day Bob was cleaning out his couch. He found a total of $9 in uh, quarters and nickels. If there were a total of 44 coins, determine how many quarters and nickels did he find. All right, so let's see here. Get my pen back up. Use the number of quarters. N is going to equal the number of nickels, right? I can write my first equation. I'm going to do Q plus N. Number of quarters plus the number of nickels must equal 44. Okay. Now, not unlike the last problem, I'm going to take 0.25Q. That's the money from the quarters, plus 0.05N. That's the money from the nickels. That needs to equal the total money, $9. Okay, I'm going to use substitution on this. I think I'm going to solve for Q. So Q is going to equal 44 minus N. So 0.25 times 44 minus N plus 0.05 N equals 9. 1/4 of that looks like it'd be 11 minus 0.25 Q plus 0.05 N. That's going to equal $9. And here I'm going to combine the like terms and get negative 0.2 Q. Of course, I'll subtract 11 from both sides, and I will get negative 2. Divide by negative 0.2, which is the same as dividing by 1/5. So we'll be multiplying by 10, multiply by 5 to get 10. So there must be 10 quarters. If there are 10 quarters, the number of nickels is, oh, I have a mistake here. That should be N, shouldn't it? And that should be N, and that should be N. So there's 10 nickels. 10 nickels. Silly mistake there. I'll tell you, the number one cause of getting these problems wrong are silly mistakes like that, because they're just so easy to do. So there's 10 nickels, right? If I do 44 minus 10, there must be 34 quarters. Of course, you can check your work. 10 nickels would be what? 50 cents, right? 34 quarters. Well, 32 quarters would be $8, right? 2 more quarters would be 50 cents. So I have $8.50. And together that makes $9. So it worked. Okay, one last problem. Same style. This time, Bocage, Jacob backwards, has 217 pennies and dimes. Well, I'm going to let P equal the number of pennies, right? And D is going to equal the number of dimes. Okay, my first equation is going to be P plus D equals 217. Now I need my money equation, and my money equation will look like this. The value of a penny is 0.01 P, value of a dime 0.10 D, and it's going to equal the total amount of money, which is $10.36. I think I'm going to solve for D. So D is going to equal 217 minus P. We get 0.01 P plus 1.0 times 217 minus P equals 1036. 0.01 P plus 10% of that is 21.7. I'm just distributing now in case you're wondering. I have minus 0.10 P equals 10.36. And got a like term here and here. That's going to be negative 0.09p. I'm going to subtract 21.7 minus 21.7, right? Now again, here I'm going to do 21.70, and I'll subtract the 10.36, and I'll just make my answer negative. So I'm going to get a 4, a 3, gonna have to borrow there. Oh no, I don't need to borrow, silly me. A 1 and a 1. So my answer is going to be a negative 11/3400. I'll divide by negative 0.09, divide by negative 0.09, and then P is going to equal, hold on one second, I'm going to have to do this on a calculator, 0.4 divided by 0.09, 126. So there must be 126 pennies, right? Well, if I look at the number of dimes, is going to be the same as 217 minus 126. Well, there's going to be a 1, and that looks like 91. So D is going to be 91 dimes, and then you can verify it. All right, that's the lesson for today. It took a little longer because I wanted to give you lots of examples, but those chemistry problems and quarter problems or coin problems are doing basically the same. All right, Mr. Lawrence signing off. Good night, everybody.